Okay, today we're going to be solving absolute value. Equations and inequalities. All right, the absolute value of a real number x written is the distance from 0 to the number on the number line. So if you're talking about the absolute value of 5, if you've got a number line and you put your 0 on it and you put 5 on it, the absolute value of a number is the distance from 0 to the number on the number line. So from 0 to 5 is 5 units. So the absolute value of 5 is equal to 5. Now, if you find the absolute value of -5, and you repeat this process on the other side of 0 with a -5, and you find the distance from 0 to the number on the number line, well, from 0 to -5 on the number line is 5 units as well. So the absolute value of 5 is equal to 5, and the absolute value of -5 is also equal to 5. So since you have two values that have the same absolute value, two values, 5 and -5, both have an absolute value of 5. For that reason, we have to solve these absolute value equations a little bit different than a regular equation. So let's take a look at the absolute value of 2x minus 1 is equal to 5. Now, the way you solve these absolute value equations and inequalities, the first step is to isolate the absolute value symbol on one side of the equation. Isolate the absolute value symbol on one side of the equation. In this case, that's already done. Here's the absolute value symbol. it and what is inside it are isolated on one side of the equation. It's just the absolute value symbol. Rewrite the equation. So once this absolute value symbol is by itself, you rewrite the equation and drop the symbol. So we rewrite this as 2x minus 1 equals 5. And then we write a second equation. Write a second equation and negate the right side. So when we write this second equation, we write the 2x minus 1 is equal to. Now we negate the right side, which means to make it negative, so equals negative 5. And then your last step is to solve both equations. All right, that works for all absolute value problems. So now we go up here to this equation on the top left and we add 1 to each side. So 2x is equal to 6. Divide both sides by 2. X is equal to 3. We solve the second equation. Add 1 to each side. 2x is equal to negative 4. Divide both sides by 2. X is equal to negative 2. And we can put the word or in here. X is equal to 3 or it's equal to negative 2. All right, let's do another one with 3x plus 2, or I'm sorry, the absolute value of 3x plus 2 is equal to 4. Since the absolute value symbol is already by itself, we drop it and rewrite. So we get 3x plus 2 is equal to 4. And 3x plus 2 is equal to negative 4. Solve both equations. So we get an x equals 2/3, or x is equal to negative 2. Those are your two solutions. The other type of problem you will see today. Now we've got 3 times the absolute value of x plus 2 minus 1, and that's equal to 8. Now we're going to isolate this absolute value symbol. And we're going to start off by adding 1 to each side. So on this left side, we got 3 times the absolute value of x plus 2 equal to 9. And since this is 3 times the absolute value of x plus 2, we're going to divide both sides by 3. And the absolute value of x plus 2 is equal to 3. And now we can solve it the way we did the first 2 examples. We rewrite. So x plus 2 is equal to 3. X plus 2 is equal to negative 3. And then solve both equations. And another one of those, it could look like 2 times the absolute value of x plus 9 plus 3 equal to 7. Same steps, same format, same concept. Subtract 3 from each side. So your 2 times the absolute value of x plus 9, is equal to 4. Divide both sides by 2. The absolute value of x plus 9 is equal to 2. Rewrite the equation twice. So we get x plus 9 equals 2, and x plus 9 equals negative 2. Subtract 9 from each side. X equals negative 7. Or x is equal to negative 11. All right, so let's write this down that the, let's see, distance from 0 on the number line cannot be negative. Therefore, some absolute value equations such as the absolute value of x being equal to negative 5 have no solution. It is important to check all solutions as one or more may be extraneous. So what they're saying is that when you solve an absolute value problem and you get your two answers, you have to plug them back into the original equation to see if they work. All right? Because sometimes you can get an extraneous solution. An extraneous solution will not make the equation true. All right? The best way I remember extraneous, okay, is just by this right here. Extra. It's an extra solution to a problem that doesn't work. And the only way you can find out if a solution is extraneous or not is to substitute it into the original equation. And make sure you do that as often as possible, especially when the directions say, what is the solution of? Check for extraneous solutions. So now we got to solve something like this. We got 3x plus 2. Absolute value of 3x plus 2. It's equal to 4x plus 5. So we're solving and we're checking for extraneous. The absolute value symbol is already by itself on the left-hand side of this equal sign. So we rewrite. We got 3x plus 2 is equal to 4x plus 5. And now we rewrite and we negate the entire right side. So we got a 3x plus 2 equal to a negative 4x minus 5. You have to negate everything over there. Change the sign of everything on the right side of the equation. So we solve this now. Subtract 3x from each side. 2 equals x plus 5. Subtract 5. Two minus 5 is negative 3 is equal to x. So there's one of the solutions. One of the possible solutions. Add 4x to each side. So 7x plus 2 equals negative 5. Subtract 2. Seven x would equal negative 7. And then you got to divide both sides by 7. So x is equal to negative 1. Now you have to check these. Okay? So we're going to substitute this negative 3. So absolute value of 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. That gives us the absolute value of negative 9 plus 2 equal to negative 12 plus 5. When we finish this, we get the absolute value of negative 7 on the left equal to negative 7. Can't have an absolute value equal to a negative. Okay? So that means that this solution is extraneous. The negative 3 is extraneous. And you still have to check the other one. You still got to check this negative 1. So we got the absolute value of 3 times negative 1 plus 2 equal to 4 times negative 1 plus 5. So that's the absolute value of negative 3 plus 2 equals negative 4 plus 5. So on this left-hand side, the absolute value of negative 3 plus 2, that'd be the absolute value of negative 1 equals negative 4 plus 5 is 1. And the absolute value of negative 1 is equal to 1. So that solution works. So here's your good solution. And the x equal to negative 3 is your extra solution or extraneous solution. Couple of kind of key points. When you negate this second equation, when you negate the right side of this equal sign, make sure that you negate both terms or as many terms that are over there. You got to negate everything. You have to change the sign of everything on the right-hand side. And then the only way to determine if a solution is extraneous is to substitute and check. Now, some of you can see right here in this step, if you substitute your negative 3 and then you glance at this right side, 4 times negative 3 is negative 12. Plus a 5 is a negative, right? Anytime the right-hand side of an absolute value equation is negative, it's an extra solution. It doesn't work, all right? So you didn't technically have to continue this out 2 more steps. Hopefully you'll notice it right here and you can stop. But if you don't, if you just keep working step by step, you'll find out if the solution is real or extraneous. All right, and then finally we're going to do some absolute value inequalities. The concept stays the same, the steps stay the same. We've got the absolute value here of 2x minus 1 less than 5. Let me go back and look at these steps real quick. Let's see. This said to write a second equation and negate the right side. So we're just going to say same steps, but in step 3, also change the inequality. Steps are the same, But in that third step, you got to also change the inequality. So we got the absolute value symbol by itself. We're going to rewrite. We get 2x minus 1 less than 5. And then we're going to rewrite it and negate. So we got 2x minus 1. Same as step 3. Also change the inequality. So look, we got to change the direction of this inequality and negate. Real big step right there. Right there. Negate and change the inequality. And now you solve them both. So we add 1 to each side. So 2x is less than 6. Divide both sides by 2. X is less than 3. Add 1 to each side. 2x is greater than negative 4. Divide by 2. X is greater than negative 2. You may see it this way. This could be an and or an or. Now, if you look at this, you got an x that's less than 3, and you got an x that's greater than negative 2. So this can be written this way. Negative 2 is less than x, and x is less than 3. You can see it either way. Make sure you understand those are the same thing. All right, if you look at these, the inequality is pointing at the x in relation to the 3. It is here as well. If you look at the second solution, the inequality is pointing away from the x and towards the negative 2. And it is here as well. So these are the same. You could have your answer choices either way. Know that if you get this, all right, if you get this or this, it's the same as this over on the right. All right, one more example, and then I'm going to leave you alone and give you some practice. So let's take a look at the absolute value of 3x minus 4. Less than or equal to 8. Same steps as the previous problem. You got 3x minus 4. Less than or equal to 8. You got 3x minus 4. Greater than or equal to negative 8. Solve them both. You get 3x less than or equal to 12. You divide by 3. You got x less than or equal to 4. On the right equation, we add 4 to each side. 3x greater than or equal to negative 4. Divide both sides by 3. X is greater than or equal to negative 4/3. And again, you got two solutions with the variable on the left, but your inequality is pointing opposite directions. So now you can put your variable in the middle. All right, the negative 4/3 is less than or equal to the x, and the x is less than or equal to the 4. Any questions on any of that we talked about today? All right, so your practice for today is going to be on page, I got a handout for you, page 46. (13 through 30). (43 through 48). All right, that's going to go in the basket or email me a picture. So e-learners, if you don't have any questions, you are excused at this time. Brick and mortars, Antoinette's going to pass out this little packet of practice pages for me. And you'll find your practice problems on it. Sean, bring me the papers that are in that basket up there, please.